Hi guys, today we will walk into data engineers day and we will see what are the challenges faced by data engineers. So like other engineers, data engineers life is also not easy. So let's get started and see what will be the upcoming challenges in a day of data engineer. So any upcoming day is not predicted. Similar to that, in our day also it is not predicted. We get some challenges. Even though there is agility and management, we don't know what comes. So tomorrow your day might start with fighting with QA on some basis, then it might start with a bug fix, or it can be a usual development day. So basically data engineer works in all these fronts, and we will see how he tackles all these scenarios in his day-to-day life. So to start with, basically in one line, if I want to say what data engineers do, is they create and manage the data pipelines. But there are many things floating around this particular basis. So in Agile framework, when we work, we have sprints. Sprint is nothing but 1 or 2 weeks of period in which we create stories. Basically, to start with, the business analyst sit with the customer to understand the business requirement. Right now they create stories, like it is a set of tasks, and they store it to backlog. And in sprint grooming session or some sprint refinement session, manager and everyone sits together and see the priority of the task that needs to be taken care, and that will be onboarded to the sprint on which you will be working. So in that sprint there will be multiple stories which contains multiple tasks. So they will provide you 1, 2 or many stories based on the length of the criticality and the priority. So once this is decided, you will get 1 or more stories to your plate, and the day one will start with that story to be understood, to be deciding what needs to be done, what will be the design of this architecture. So there will be 2 things. One thing is either you will be creating everything from scratch, and second thing is you might be changing some transformation logic based on the business requirement. So one is complete creation, another is some modification. In both kind of stories, data engineer do one thing: it either manages or creates the data pipelines. So to start with, suppose it's my first day of my sprint and my day started. So I'll go to the story and see what is the description, what are the points, bullet points provided by business analyst by discussing with the customer. If I have any questions, I need to reach out to them and clarify the requirements first. And if I am very clear about the requirement, what I'll do is I will start designing the actual architecture that I need to do as part of this use case. So in any case, if I am working as a developer or a data engineer, I will be doing extract, transform and load, which means a data pipeline which is also called as workflow needs to be created. So there will be a source, and we need to connect to that source. It can be RDBMS, it can be a streaming source, it can be a file source, and based on that you need to write the connectors and everything in programming language, and you connect to that source. Once connected, you just collect that data as it is, which is called as a raw format. That is why this particular architecture is called as data lake, where we collect data in raw format, then we do some transformation based on some business logics, specifically using SQL language. And once it is done, we will do some load in some data warehouse or file storage, or directly push it to reporting tool. So there will be 3 kind of what we say users to this data that we process with the help of this pipeline. One is a data warehouse, where we can just dump the data and people can analyze using the queries. Second, we can directly load it to some reporting tool to create the reports and dashboards. Third is like there might be some another team which is your downstream, and they need that data in the tables. All the scenarios you will load the data. So you did a extract, you did a transform, you did a load in a complete workflow of a specific table. So your story will be saying that you need to create a data pipeline for XYZ table. So for that XYZ table, you created extract, transform, load throughout end to end. Similarly, you might migrate or you might create 2 to 3 tables, 4 tables, 5 tables, depending on the table type. and its criticality. So coming to the table type. So table types can be full load or incremental load. Some tables like dimension tables are full load. It is just a matter of loading everything, deleting, clearing and loading data. But in case of incremental load, you may run the workflow multiple times in a day, every day, weekly, monthly. There can be a schedule to that, and it can be decided based on some date value. It can be creation date, transaction date, batch date, some date, after which you need to refresh the data and pull it to your system. So it is an incremental load, and you need to consider these two types of tables. You first understand that these tables are story has this kind of tables, and you need to create your workflow accordingly. Then you need to ask for the schedule. What can be the schedule of this? So that depends on data behavior, how the data will come. Is it a time series data? Is it some static data which don't get frequently modified? So accordingly you need to set the schedule of that workflow. So this is basically a complete workflow design that we follow. There is one more thing is, in case of incremental load, there will be a batches of data, which means chunk of data. There is a batch like which runs every hour, for example. So there will be some sort of algorithm that we need to maintain to make sure that every time we pull the latest data. So we might need a coordinator table or an audit table to make sure that we are managing batches properly. And suppose we need to run the previous batch, we should know some batch number or batch ID, and we can rerun that particular batch. So to handle those failure scenarios, there will be audit table which we maintain. There are some metadata tables as well to our sync and source, which you should understand how they work. They contain all the details of your source database, your target database, be it a cloud or on-premises or hybrid architecture. There can be multiple ways to get into the metadata. Another thing you need to consider is the configuration files. So there can be deployment files like YAML files, there can be INI files, there can be properties files, or there can be normal JSON or XML files as well. And based on what type of configurations you are using in your workflow, you need to use those files. For example, we can use INI files for the preparation of every job, and there can be YAML files for the cluster template which we deploy. So there are configuration files. I need to be aware of what kind of configurations I need to do when it comes to resources as well as my programming. So when I say programming, there are two ways, and accordingly there are two kind of repositories that I maintain in my whole architecture. One is ETL, another is data model. ETL contains the ETL scripts or code. It can be Python scripts, it can be Bash, Java, Scala, or any programming language that will work as a wrapper or driver modules which are written, which will run one after the another as a script. So that source code contains in the ETL repository, and data model will contain the SQL files for DDLs and your transformation SQL logics that you can store. So basically overall idea is my ETL code will run the scripts. It takes input as a SQL file and it will run those SQL on my resources, which are ideally on cloud or on premises. On premises data warehouses can be Hive, and your AWS can have Redshift, which can be your target. BigQuery, again you can store data on S3. Your GCS location in Azure also we have those Azure data locations. So it can be anything. And also when I say that in a data lake we store data on raw format, so first there will be a raw layer which will store data on S3 or GCS kind of locations. Then there will be a transformation layer, and then final data will be stored in the data warehouse. So you need to make sure that you are providing checkpoints to these steps. You are taking backup of each stage, and then you are finally storing data to the final table. In this scenario, you might end up with append only tables or files in case of raw zone, and there will be merge statements while merging the final output to the final table, because we want the updated data on our data warehouse. Because in the concept of data warehouse, we usually don't do manipulation of data very frequently. It's not a transactional data set, it's a analytical workload. So that's why we usually go on appending data and merging it to the data warehouse using the scripts. So my task as a data engineer is usually dumping data to the specific data warehouse by using some SQLs, by performing some SQL operations, before that connecting to a source, right? And once the data is available in data warehouse, make them available through connectors or something to different stakeholders, which can be downstream, which can be reporting, right? So this is the overall idea. Now coming to the deployments. So there can be releases which can be sprint level, which can be, we can club multiple sprints and do it a monthly, 2 months, 3 months. It depends on the criticality, how early you want your code to go. So in the before going to releases, once you go, you do your programming and you are done, like you did unit testing as well, then you can promote to the different environment, which is a QA environment. So there should be multiple environments in your project: dev environment, QA environments, where QA will test the data through multiple data sets, the same code. If they find any issue, they will raise a bug. If you need any clarifications, you need to provide. After that, they will give you the QA sign off. Then there will be a SAT environment which will do some performance testing on SAT. If everything is good, SAT sign off will do. Then there will be a UAT environment where there will be a production like data and we run on that. If we face any configuration issues, cluster related issues, we can find in UAT because it's an integrated test. Once that is signed off properly, then we will migrate it to production. And also, to maintain the high availability, we can make sure that resources are in different regions and different zones. Like for example, EMR cluster can be in US East one, EU Central one, in any region, so that if anything is failed, any particular zone is failed, you can just make sure that another is running. So you need to make sure that if it is, that is a kind of DevOps work, but you should also know what is happening in the background. So this is all about how a pipeline works. This is not a single day task. You need to give a complete sprint to migrate these kind of tables. And if it's not a complete creation of data pipeline, if it's a modification because of some issue that customer is facing, then first step is you need to recreate the issue and then start developing it and then run after the development, so that you can compare previous issue was this and now it is resolved. So this is how you can make sure that modifications to the transformation logic are done. Before and after scenarios, you can attach it to your Jira and make sure that everything is available as evidences. Then there will be some retrospectives going on in your sprint. Your Scrum Master will call out what went good, what went wrong, what can be improved, and based on that inputs, you can improve yourself in the next sprint. But of course, there will be new challenges every day. Suppose yesterday deployment happened to production, today there are new workloads, but still you need to focus on post data validation for the last release, or there will be some bugs in production that came to you and that is a high priority now. So this can happen, and based on that, you need to manage your work and provide the estimates. While providing the estimates in your sprint refinement itself, sprint grooming itself, they will ask you for the work, like what will be the story points, what is the effort. So always make sure that you provide a effort with some buffer, so that when some issues will come on upfront, then you can cope up with your existing stories as well. So you have multiple things to do. You may need to assist to QA, you may need to do some validations, you may need to support production jobs if needed, and along with that you need to do the regular data engineering work, which is creating the data pipelines either on premise or on your cloud. The overall idea of this data engineering is same, that doesn't change, and the efforts or whatever the amount of efforts it takes depends on what is the source, how long it takes. So suppose your source is a JSON file coming through a streaming source, then you may need a good development effort, because you need to parse that JSON accordingly, right? If it's a normal RDBMS, you just take the data using query, you load the data. So that's not having a greater efforts. In some projects you will have a wrapper or driver program, and you just need to create configuration files whenever new table comes. So their efforts is less, because there is one transformer script already written. It just takes the input and does this ETL using the same script. So there are different projects, depending on that there are different requirements, and handling of requirements might change. So this is a overall day that a data engineer spend with a lot of challenges when it comes to development, as well as these will test your stress ability, because most of the times production is high priority and you also need to do your regular development work. So it's always been a roller coaster ride if you are new. If you are more experienced in the data engineering, you will foresee some issues that can happen, and you can tackle those issues as early as possible. I hope this video will help you a lot, and if you need to add anything to this video, you can drop into comments so that others can just grow their knowledge when they are just entering into this field, or they are trying to grow in this field. And I hope this helps. All the best.